Hello everyone. In this video we will take some examples of converting a decimal number system to an octal number system. In lecture 4 of this course we did study how to convert a decimal number system to a binary number system. Now we will use the same method to convert the decimal number to the octal number. To convert integer number from decimal to octal, divide the number by the base 8 until the result finally becomes 0. Traverse the remainder from bottom to top to get the result in octal. Let us take an example. Convert the decimal number 372 to octal. Make two columns, integer and remainder. Divide 372 by the base 8 gives 46 with a remainder 4. Then divide 46 by the base 8 gives 5 with a remainder 6. Then divide 5 by 8 gives 0 with a remainder 5. Now traverse the remainder column from bottom to top. So the number 372 in decimal is equal to 564 in octal. Let us take another example with decimal point. Convert the decimal number 85.76 to octal. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part of the number, which is 85. Make two columns, integer and the remainder. Divide 85 by the base 8 gives 10 with a remainder 5. Then divide 10 by the base 8 gives 1 with a remainder 2. Divide 1 by 8 gives 0 with a remainder 1. Traverse the remainder column from bottom to top. So the number 85 in decimal is equal to 125 in octal. Now we will convert the fractional part of the number, which is 0.76. To convert fractional number from base 10 to base 8, multiply the fractional number with 8 until the fractional number finally becomes 0, or stop after required decimal places. Then traverse the integers from top to bottom to get the result in base 8. Make two columns, fraction and integer. Multiply the number 0.76 by the base 8 equal to 6.08. So the fractional part is 0.08 and the fractional part is 6. Then multiply the number 0.08 by the base 8 equal to 0.64. So the integer part is 0 and the fractional part is 0.64. Then multiply the number 0.64 by the base 8 equal to 5.12. So the integer part is 5 and the fractional part is 0.12. Multiply the number 0.12 by the base 8 equal to 0.96. So the integer part is 0 and the fractional part is 0.96. Multiply the number 0.96 by the base 8 equal to 7.68. So the integer part is 7 and the fractional part is 0.68. Then multiply the number 0.68 by the base 8 equal to 5.44. So the integer part is 5 and the fractional part is 44. Multiply the number 0.44 by the base 8 equal to 3.52. So the integer part is 3 and the fractional part is 0.52. Multiply the number 0.52 by the base 8 equal to 4.16. So the integer part is 4 and the fractional part is 0.16. Stopping at 8 decimal places. Traverse the integer column from top to bottom. So the number 0.76 in decimal is equal to 0.6050754 in octal. Now we will add the two converted parts together. The converted integer part for 85 was 125 plus the converted fractional part is 0.6050754, and this is equal to 125.60. So the number 85.76 in decimal is equal to 125.6050754 in octal. This course is sponsored by the Logic Kit app, where this app is made for teachers and students who are involved in studying the computer. With the Logic Kit app, you can learn and solve number systems and Boolean algebra with step-by-step solutions. Let us use this app and convert a decimal number to an octal number, and see how this app explains the steps. In the Convert Number section of this app, we select the input base, which is 10, and the output base, which is 8, and write a decimal number, for example 865.329. As you can see, the equivalent octal number is 1541.2503453. Now let's see the steps. As you can see, the app first converted the integer part of the number, and doing the calculations was explained step by step that you can follow to understand the solution. Then you see the steps of how to convert the fractional part of the number. Also, the steps are explained very well. At the end, it added the two converted paths and give the final solution. This app is giving you the ability to convert from any base to any base up to base 36. Also, by this app, you can find the complements and do arithmetic between numbers in different bases. And in the Boolean algebra section, you can do a lot of things like minimize the functions, solve the Karnaugh map, deal with truth table, and many other things. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel, follow us on Facebook, and visit our website. Also, we made a Telegram channel that you can join. All links are in the description.